Also, for the first question, a unity feedback control system with the following open loop transfer function is proved G GS multiply HS equal to K over S is S plus 2 bracket S plus 4. So the first requirement is to draw the approximate locus diagram. So here we will do first. Okay. For the first GS GS like HS will be equal K over S S plus 2 and S plus 4. Here, the limit will be equal to 0 and n will be equal to 3 and s will be equal to 2, 4, negative 4 and 0 and 0. And theta, the angle will equal to 13 plus 1 over 3. So the angle will be 60, 60, 180 and 300. And A will equal to approximate E to over n minus m will be 0 minus 2 minus 4 over 3 will be negative 6 over 2 will be 2 will be over 3 it will be 2. And for the graph we have here im and this is negative 4, this is negative 2 and this is 0. We have break away. So K will be equal negative S plus 2 S plus 4 multiply TK over DS will be equal 0. So D over DS for S and S plus 2 and S plus 4 will be equal to 3S squared plus 12S plus 8 equal to 0. So S will be equal to, so it was negative 2 positive or negative 2 root 3 over 3. for S1 will be equal to negative 0.8453, and for S2 will to negative 3.155. We will probably will take this, and second, you want for B 1 plus K over S plus 2 S plus 4 multiply S equals 0. So S plus 2 S plus 4 by doing some simplest form plus K bracket to equal to S cubed plus 6S square plus 8S plus K. We will just forward from S cubed S square S power 1 S power 0. Here we have a 6, we have a 1, we have a 6, we have 48 minus K over 6. Here we have K, and K will be greater than 0, and 48 minus K greater than 0. So the K will be greater than 0 and smaller than 48. So your time response time response 0 will be between 0 and K and 3.155, and K equal to 3.155 and 3.155 K and 48 at S equals 6. This will be equal to positive or negative J 2 root 2, and K will be greater than 48. So for the second thing, in the result, all needed step to draw the Lucas diagram by doing same process in MATLAB inversion. We can do screen for MATLAB. I already write that before. So this is the code, and this is the graph for the circuit. This one is when K equal 48, and this one is the case between 48 and 3.155. In the second question, there are three op-amps connected to the cascade in the control system. The waveform are shown on the side according to this. This is input and this is three output. Draw the approximate connection and find the parameter values used. If the op-amp used in the circuit are connected in the parallel and the pass through the collector with gain of 1, the transfer function and interrupt what is the circuit is and the event system in MATLAB and show on the graphics. So for the first, we have to find parameters A, C, so, so input is the constant is 1 volt is constant equal to 1 volt and we have three outputs. For the first output, first output is equal to negative half volt. So is inverting amplifier amplifier. So the G1 will equal B B negative RF over negative R1 will be negative 0.5 volt and RF1 will equal to 5 kilo ohm and R1 equal to 10 kilo ohm. And output V out equal to negative 1 over RC integration V out 1 for dt. Should be from 0 to 0.5 dt will be equal to 4 and there is a negative over RC. So RC equal to 0.5 and R equal to 500 kilo ohm and C equal 1 microfarad. For the third output, V out P equal negative RC dV out, second dV out over dt to equal to negative RC by 1 equal negative 1 G to 1 volt. So the RC will be equal to 1 and R equal to 1 mega ohm and C equal to 1 micro 1 microfarad. B which n of S equal negative 0.5 and second one equal H2 S equal negative 1 over 0.5 S equal negative 2 over so H S will be equal for HS1 and S2 and HS3 and H3 will equal to negative 1S. So it will be negative 0.5 plus 1 plus 2 over equal to HS will be negative square plus 0.5 S plus 2 over 5. So act as BID as parallel BID as parallel BID. I'm gonna show in the MATLAB. This is the code and this is the graph for the unit response. This questions the open loop transfer function of unity feedback control given system feedback column system is given below GS equal to 10 over S multiply S plus 5. System type and continuous state error specify the type system type 0 type 1 calculate the continuous state error for unit digit input if the unit RAM input is applied for the same system find steady state error conversion with standard quadratic system closed loop characteristic equation is square over 2 is not omega s plus omega square n equals 0 by comparing it to the standard second order system from form find exactly the following the natural frequency of the system omega n and the dealing rate of the system. Is equal to 10 over S plus 4a. It is for type 1. Okay. unit. Tip E S S cable. Cable can be equal to units OS 10 to 0 GS equal to limit S plus 0 10 over S plus 5 equal infinity. E ES equal to 1 over 1 plus K B equal to 1 over 1 plus infinity equal to 0. C B unit literal in KV equal limit s tends to infinity for s multiply vs equal limit s tends to 0 for s multiply 10 over s over s plus 5 equal 10 over 5 equal to. So the ESS equal 1 over KV equal 1 over 2. That's the second. So the S plus 2 sin omega n omega n S plus omega n square equal to 0. 1 plus G is equal to 0. 10 1 over 10 is 10 over S over S plus 5 equal 0. So it will S square plus 5S plus 10 equal to 0. So A omega n will equal to omega omega n equal 10 for omega n equal root 10 equal 3.16 approximately of course rad per second and B equal to omega n equal to 5. So the equal 5 over 2 omega n equal 5 over 2 is 5, 5 to 10 equal approximately to 0.79. So it is on the laptop. This is the code, and this is its graph, the step response.